Hello. Today we're going to talk about something I just bought from Amazon. I think it was a very good deal, under 15 bucks if I recall correctly. Anyway, it's a power supply, a very low power supply. So if you only do like toy projects, you don't need much current. This is kind of perfect. It only goes to 200 milliamps max. So you can't really do that much with it, but you can do like small circuits, which is good enough for me. Anyway, so this is the page 1 of the instruction manual. So this comes in kit form, so it tells you what to do. Let me zoom in a little bit. That should be more than enough. So they are nice enough to give you some pointers about how to solder. So this is the right way to solder. So you have that nice cone and it's shiny. You don't want to have the cone and have like not shiny, like blackened, because it's too much. That means too much heat. So this is the LM317. So that's your voltage regulator, the actual voltage regulator. This is the voltmeter. So when you, and this is the pot here that controls the voltage, the output voltage. So it's nice enough to show you the actual voltage on the output. Also, you can use it also powers that blue LED. So the brighter the LED, the more voltage. So you have like two kind of visual aids in determining how much output voltage you are getting. I mean, I think the max is 12 volts and the minimum is 1 point something. Anyway, it's not just a power supply, it's also a signal generator, a square wave generator, and it's also a logic pen. More on that in a few seconds. But first, I just want to point out that here, this thing is this thing. It's a CD4069, so it's an IC that contains six inverter logic gates, so 6 NOT logic gates, and that's what's being used for the, I think it's using 3 for the square wave generator and 3 for that logic pen. Anyway, so the output ground, that's your output voltage, so the DC voltage. This one, this pot here controls the frequency of your square wave. And this is the input. Oh yeah, so this is your input for the buzzer. This is the output for the signal generator, and this is the input for the logic pen. So what you can do is that you can just short circuit the signal output, so the square wave, directly into either the buzzer or into the logic pen. So what happens in that case? Okay, first let's go back. This LED, that yellow LED, it's gonna flash, and that's it shows the lows and the highs of the square wave. So the square wave generator always outputs something, and it's shown here. Even though you don't ask for it, it's gonna flash here. This one is gonna flash very slowly. And you can make it flash a little bit faster by playing with this pot. It's not going to be very fast, but you can play a little bit with it. And those two LEDs, the low and the high, that's the output from the logic pen. So basically, if the input into the logic pen is a low state, so let's say 0 volt, this is going to shine, the green one. And if the input is a high, like let's say 5 volts, this one is gonna light up. So when you connect the signal generator output directly to the logic pen, what's gonna happen is that the yellow is gonna flash. Of course, it always flashes. but those two are gonna flip-flop. So this is the output from the logic pen. So when your square wave is at the low, this one is gonna be lit up, and when your square wave is at the high state, this one is gonna light up. And the buzzer is pretty much the same thing, except that instead of having a visual cue, you're gonna have like a sound cue. So the buzzer doesn't sound when it's at a low state, and the buzzer sounds when it's at a high state. So what you can do again is to hook up the output from the signal generator, the square wave generator, into the buzzer, and you're gonna get like a beep, 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 something like that. You get the idea. What else can I say about this circuit? Yeah, so it's very easy to build. And as you can see, the transformer is very small. I think it's 2 watts. That's why you don't get that much power on the output. Okay, so let's have a look at the next page, because it's actually pretty good. On the right, it explains how each circuit works. Let me zoom in a little bit. Okay. Okay, let's go to the top. Okay, so it explains that there is a. It's too big. So here, 1, that's the power supply, and it explains how it works. 2 is the signal generator circuit, so the square wave circuit. So 3 is the logic pen circuit, and 4 is the buzzer circuit. And it gives also installation instruction. You should read them, by the way. I didn't read them, but I didn't realize they were there. But it helps. Not in the soldering step. It's more into which screw goes where. Okay, so let's look at the circuits. That's the interesting part, and I think they did a good job here showing the circuits. Very nice. Okay, I think, let me see if I can go. Okay, that's pretty much, yeah, that's pretty good. Yeah, that's pretty good. Okay, so the top one, that's your power supply, so it's very simple. And it connects directly to AC, by the way. So you have your transformer, goes to 12 volt AC, you have your bridge rectifier, you have the filter capacitor here, you have the LM317, which is your voltage regulator, and you have your output here, and this is that blue LED I was talking about. So the brighter it is, the more output voltage there is. So that's an easy one. The next one. Okay, let me see if I can do even bigger. Okay, so the next one is the square wave generator. So this one, I made a video about it, so I'm going to put the link right now. But basically it uses 2 logic gates here just to get the square wave. Actually, you don't need that one, but it's better to have another one to clean up the signal and to buffer it, so that at the output you have a nice square wave. So this circuit here, I explain it in that other video. Okay, so then it's using another gate. So again, it's a NOT gate or an inverter gate. It's just to clean up the signal. And it uses the yellow LED to show the state. So if it's low, the LED is not lit. If it's high, the LED lights up. Okay, next circuit. So the next circuit is this logic pen circuit. So the input is either high or low. So let's start with the input being low. So what happens when the input is low? Low here, high, low. So at the top it's low, and at the bottom it's going to be high. So the current can only go this way, from high to low. So it means that the green LED is going to light up and the red LED will not light up. If you invert the input, so if this is high, this input is high, low, high, and here it's low. So you go from high to low. The green LED is not going to light up, but it's the red LED is going to light up. Okay, remember that those are inverter gates, not gates. So when this is high, this is low. When this is low, this is high. Same for all of them. So what happens that if you have a square wave here, the two LEDs are gonna flip-flop. That's the gist of it. It's another very simple circuit. So there is another circuit. So there are actually 4 circuits in that board. And this one is very simple. It's even easier than the other one. It's just a transistor acting as a switch. So if your input here is low, like 0 volt, nothing's going to happen. If your input is high, the transistor is going to turn on and the buzzer is going to sound. So that's a very simple circuit, and it's just a transistor used as a switch. Okay, I think I'm going to show the thing in action next. And here it is. So here I'm going to increase the output voltage so that the LEDs light up. So we have the blue one, we already talked about that one. We have the yellow one that's flashing, coming from the square wave generator. And you have the red LED that's turned on. It seems that if you don't plug in anything into the logic pen, you have a high output. But here I'm hooking up the square wave generator's output into the logic pen, and now you can see that the red and green LEDs are flip-flopping, and you notice that the yellow and the red LEDs are in sync. They both represent the high state, so let's like 5 volts, or in this case 2.31 volts. And next I'm gonna hook up the output of the square wave generator into the input of the buzzer, and it should sound. Okay, enough of that. Oh yeah, you can change the frequency by playing with that pot as shown here. It's not gonna change much though. And here I'm just showing on the scope what the square wave looks like. It's nice. And here I'm just increasing the voltage, that's why it's going up. As you can see, it's very slow moving though. So here it is in all its glory. And yeah, I'm just lowering the voltage. I mean, enough of that, okay? Yeah, here is the thing close up. In my case, the input to the buzzer was not connected to anything. It was supposed to be connected to one end of R6, but in my case I had to add a wire otherwise nothing would happen. So it's just a warning out there. I'm gonna stop here and I see you around. Bye.